Welcome back to our last video for Unit 9A, Day 4, arc length and circle sectors. So we already talked about arc length, how it's going to be not the degrees, not the measure, that there's a difference between the measure of a length, which is going to max out at 360, and our arc length, which is going to be different, can be any size, big or small, depending on the radius of our circle. Because all circles have a measure of 360, but this circle, although it's 360 degrees around, will be a much smaller length than the length around this circle that has a bigger radius. Okay? And then we talked about using a formula where you take your fractional part of your circle and you multiply it by the circumference to find out, well, what if we don't want to go all the way around the circle, right? So what if we don't want to go, what if we only want to go 120 degrees, right? So the fractional part is going to be the 120 out of the 360. We reduced it, and then you multiply that to the circumference, right? So if I want to go 270 degrees, we figure out what is that fractional part, and we multiply it to the circumference, 3/4 times 96 pi. Same thing here and here. So that's what we did in the last video. In this one, we're going to focus not on the length around the circle, but the area inside the circle. Okay? We know the area of a circle is the area, all of the area inside of it, the whole circle. The sector area is going to be just the area of the circle sector, which is part of a circle bound by 2 radii and an arc. Okay, so 2 radii and an arc. Meaning, if I have a circle and I draw in 2 radii, okay, so my sector is going to be 2 radii, 1, 2, and an arc. So the area of that circle sector is going to be all of this. Okay? All right, so my next question says, well, what is something we can think of that when we see that shape, something we think of? Because I missed breakfast this morning, the first thing I'm thinking of is food. So the main things I think of when I think of this shape is I think of like a piece of pizza, right? Or pie. Not pie like we use in math, but pie like we eat at Thanksgiving. Okay? Or when you're playing Trivial Pursuit, right? You have the little pie pieces. Or the spokes on a wheel. Will create a circle sector, right? If you have your bicycle and it has all your spokes on it, or your car tire and it has all the spokes on it, it's going to create all these little sectors, right? Or Wheel of Fortune, right? If you've ever watched Wheel of Fortune and they land on some of those, they get to pick up the little wedge. That's a circle sector, okay? So if we want to think about finding just part of the circle sector, we don't want to find the whole circle's area, we just want to find just that one part. It's going to be similar to finding just part of a length, right? So how would the method be similar to the method used for finding the arc length? Well, just like when we found the arc length, what we did is we multiplied the length of the whole arc by the fractional part of the arc, right? So we're going to do that same thing here. We're still going to be multiplying by the fractional part, because we don't want to go all the way around. We only want to go however big this angle here is, right? We don't want to go all the way around. We only want to go that much around, okay? But how would the method be different? Because if we're not finding arc length, if we're finding sector area, how would the method be different instead of the same? So it's the same because we're going to multiply by fractional part. But what becomes different is instead of multiplying that fractional part to the circumference, which remember your circumference is just the outer edge, instead of multiplying to the circumference, we're going to multiply to the area of the circle instead of circumference. just barely fit that in there. Okay, so we're going to multiply to the area of the circle instead of multiplying to the circumference. Okay, so when I look at this first problem, it says if the circles below have a radius of 15 centimeters, what would be the exact area of the shaded sectors? So all of these have the exact same radius. They all have 15 millimeters, which means they all have the same area. I'm going to squeeze that in over here. I know my formula, and if I don't, I can go look at the formula chart. My area is pi r squared for a circle. So pi times 15 squared. And 15 times 15, I believe, is 225, but I like to check it in my calculator. 15 times 15 is 225. So these are all going to be 225 pi. That is my area for each one of these circles. Okay? All right, so now we want to figure out, well, what is our fractional parts that we're going to multiply to that area? So when I start with my first circle here, I can see it's 120 degrees out of the 360 degrees, which reduces to, we already figured that out in the last video, 12 over 36 reduces to 1/3. 12 goes into 12 one time, 12 goes into 360 3 times. So my fractional part is 1/3 times the area. The area is 225, and I'm going to do like I did on the last one, 225 over 1 pi. So I just changed that into a fraction also. So that way, all we have to do is multiply straight across. So I'm going to have 1 times 225 over 3 times 1 pi. Let's see, is 225 divisible by 3? 225 divided by 3 is 75, so it works out perfect. 75 pi. And since this is area, these are going to be millimeters squared. Okay, so that's the area of just this shaded portion, whereas the whole area would be 225. Okay, let's look at the next one. For the next one, I can see I have that 90 degrees in there, but remember, I don't want the unshaded portion, I want the shaded portion. So I want this angle back here, which is going to be 360, the whole circle, minus the 90, 270. And 270 out of 360 reduces to 3/4. 9 goes into 27 3 times, 9 goes into 36 4 times. Okay, so I'm going to do 3/4 times that whole area. The whole area is 225 pi. I'm going to do 225 over 1 times pi. 3 times 225. 3 times 225 is 675 over 4 times 1 is 4 pi, and I don't know if that reduces evenly. Divided by 4, it does not. And if I divide by 4, let's see, is there anything? 4 doesn't go in there, 2 doesn't go in there. So since 4 and 2, neither one go in 675, I can't reduce that any lower. So that I can leave it exactly like that. When I divide 675 by 4, I do get an answer of 168.75, and it's not, it doesn't keep on going. So you could change that into a decimal, or you could leave it just there like that. Okay? All right, the next one, what would be the exact area of this shaded sector? So when I look at that one, I'm going to have 144 is my angle in there. So 144 out of 360. Okay, so 72 goes into 144 2 times, and 72 goes into 360 5 times. And I kind of cheated because, right, we already did that up here, 144 divided by 360. Last time I didn't know that 72 was what divided both of them evenly. I went with 12 and 12, and then I reduced that further, 12 bits. 2/5. That's my fractional part that's going to get multiplied to the area. The area is 225 pi. So I'm going to write that as 225 over 1 pi. 2 times 225 is 450. 5 times 1 is 5. That definitely reduces. 90 pi. Okay, all right, one more of these. All right, my last one over here. I've got 60 degrees here, so out of 360 degrees, if I take away 60, I'm left with 300. So 300 out of 360 becomes 5/6, because 6 goes into 35 times and 6 goes into 36 6 times. So 5/6, that's hard for me to say, 5/6 times 225 pi, I'm going to do that as 225 over 1 pi. Let's see, 5 times 225 is 1125 over 6 times 1 is 6 pi. And let's see if that reduces. 1125 divided by 6 doesn't reduce evenly, but let's see. Is there anything that can go into both 6 and 3? 6 goes into 6, but it doesn't go into 1125. But does 3 go into 1125? 1125 divided by 3 is 375. So 3 goes into 1125 375 times. And 3 goes into 6 2 times. So that's going to be 375 over 2 pi is the area of the shaded portion for that circle. So all of those circles have a total area of 225 pi. If I go 120 degrees around the circle, it's only 75 pi. If I go 270 degrees, it's 675 divided by 4 pi. If I go 144 degrees, that's only 90 pi out of my 225 pi. And if I go almost all the way around, if I go 300 degrees around my circle, it's 375 divided by 2 pi. Okay? So as kind of a recap, we looked at the formula for finding arc length in the last video. We said you take that measure of the arc and divide by 360, because that gives you the fraction that you need to multiply by. And then we multiplied that by the circumference to find my arc length. To find my sector area, well, how did I get these fractions that I multiplied? I did that same thing that I did for arc length, right? I did the measure of the arc over 360. That gave me the fractional part that I needed. But instead of multiplying to the circumference, we're now going to multiply to the area. Over here, my 225, I'm multiplying to the area. So those are my two formulas that I need for finding arc length and sector area. Remember, they're going to be different from the measures of the arc. So you always have to pay attention to your problems and say, is it asking me to find the measures of the arc? Is it asking me to find the arc length? Or is it asking me to find the sector area? So always make sure you're reading your problems to see what are they asking me for. That's all we have for this lesson. If you have any questions or need to see further examples, please make sure you attend sync time and ask questions either during sync time or during the tutoring that follows sync time. Thank you so much for watching.